Okay, we're going to get started. So before I begin, just my usual shtick. Hope everyone isn't getting too tired of it. My name is Stuart Weiler, the Director of CAD and PLM at Elite. We are part of the Elite Aerospace Group, speaking to you from the Elite Engineering Services. Today we'll be looking at Creo Simulation Live. So just quickly a little bit about Elite. As I mentioned, we're part of the Elite Aerospace Group. We've got a couple different divisions. Mostly like to just mention it because that means that we have factories that are actually producing manufactured goods. We have mostly subtractive manufacturing. We have a little bit of additive, which is currently running, producing face shields at the moment. And in our factory, we use PTC products such as Windchill to manage all of our data, Creo to do some of our design work and such. And of course, our engineering services division creates a lot of engineering data. We do a lot of engineering design, some of it for manufacturing in our facility, and some of it as work as consultants as well. And then we support all of the PTC products. You can see them listed here: MathCAD, ThingWorx, Windchill, Creo, Vuforia. And we do all the services that go along with it. So if there's anything that you need regarding PTC products, we're here to help you with that. And also we do things like this to help you see what's new and what's the latest technology. So today is Creo Simulation Live, which has been around for a little while now. It's still a pretty new product, but Creo 7 has just been released, and that actually adds some additional functionality to Simulation Live. So we're going to look at what was previously available in Simulation Live, and as well, we'll discuss some of the additional features and functionality now available. So with that being said, I will pass presentation over to our guest speaker today, Paul Dye, who is from the PTC Virtual Center of Excellence, who's going to give us a look and a demo into CSL. And of course, if there are any questions, you can put them in the chat session, or at the end of the session, you can unmute yourself and ask away. So Paul, whenever you are ready, we appreciate the demonstration.
Yeah, no problem. Thank you for having me. And again, my name is Paul Dye. I'm an application engineer here with PTC, and I primarily work with Creo. And this is one of the really cool things that we have with Creo now, and something that, like Stuart mentioned, is relatively new in the context of Creo, but actually has been worked on and developed for a lot before actually it was even part of the Creo suite of tools per se. So I'll go through and explain a little bit about how that works, some of the functionality that we've had in Creo, and then again, some of the new things that we have with this new release of Creo 7. And quickly to go over what we're going to see is first in with the challenges that really we look to address in the typical world of working on design and how the analysis and our simulation kind of works into that, or even some of the problems you might be seeing currently in the systems you're working right now. And after that, we'll go through our solution to a lot of those challenges with Creo Simulation Live. I might also refer to it as CSL, just a shortened acronym for it, but and then we'll go with that. We'll go through the capabilities, some of the new functionality with it. And then after that, I'll go through a demonstration of the tool. And really around that, I'm going to go through multiple different examples so you can see really the wide scope of where this fits in and exactly how we like to utilize it in the context of Creo. After that, we'll go through some of the real advantages that we get from Creo Simulation Live. And then at the end, if we have any questions, I can go around and answer them. So feel free to drop those in or ask away at any point. And with that, we can get started. And so here, laying the foundation with some of the different challenges. So whenever we think about analysis, just in general, it's really seen as too time-consuming to really utilize properly in the earlier stages of the design. And that's really because our models are always in a constant state of change. And most times we don't have the time necessary to run the analysis because normally it's fairly time-consuming. What that leads us to is pretty much our designers and our engineers relying on experience or just simply some intuition when we're making fairly critical design decisions. And that means that the design decisions that we're making a lot of times aren't really backed by anything but intelligent guesses or maybe some manual calculations. It's definitely something that we want to move away from. If you do go through and do any analysis, it's always in the late stage portion of the design. It's more of a pass or fail. And if you have errors that aren't caught until then, well, that's a lot of rework. That's a lot of time that it takes to go through and fix on that, which is really attributed to our inability to support any type of analysis-led design, where if we could have got some of that insight throughout the process and built around that, then we wouldn't have this type of rework that we typically see towards the late stage processes. And all that really leads back to a reliance on things like physical prototyping and testing to actually validate on the performance of our designs. Because we still do need a way to validate the decisions that we're making, but throughout this, it leads to having two very separate worlds in this, where we have one in the beginning in the early stages for our designs and our iterations, and then another separate world that we do our analysis and our validation in the later stages. And what we're really looking to do is to break down the wall between those two worlds and work more in one unified modeling and analysis environment. And our way of doing that in the world of Creo is with our Simulation Live extension. What we've done is partner with ANSYS. If you've ever worked with them or even heard of them in the past, they've been the leader in engineering simulation over the past 48, 49 years. And what we've done is actually embedded what they have in their Discovery Live simulation engine and put that natively right into Creo Parametric. So it's not even some separate window or even another software normally that you have to go in to work with it. It's just embedded right in the Creo Parametric tool. So right as we're making changes, do this work right alongside it. And the Discovery Live engine that this is running off of is using a very powerful linear solver and gives us the ability to perform static analysis on both the part and the assembly level. And we're able to rapidly start to go through, define, and perform these different types of analysis: structural, thermal, modal, and actually with Creo 7, like we'll see the ability to do flow analysis as well. And one of the big really hurdles that you typically find in working with an analysis tool is building out the mesh and getting everything set up and defeaturing everything to get it to run through properly. Because normally you have things like interferences, singularities that normally if you have those in your model, it's not going to run properly. And you can't even get into the analysis, right? So there's a lot of time that's spent getting it set up to even get into that part of the analysis. But that's not a thing in the world of Creo Simulation Live. We're working completely in a meshless environment. So because of the way that this engine's been built out, we're removing the need to manually create a mesh right on the model. What that allows us to do is go right into the analysis. And the results that we're getting from the analysis are instantaneous. That includes even when we go through and make changes. So changes to the part, change around the materials we're using, even make changes to the analysis definition itself. If you want to try out different loads, different constraints, go ahead and do that. And you can instantly see how that changes the results that you're getting. Now, this entire process that we're running is running seamlessly right in the modeling environment. So it's right in the same parametric environment that you're used to, and it's extremely easy to access. All we do is click up at the top at our Live Simulate tab, and then we can begin to go through and start to define the study that we want to work with. And everything that we define appears over here on the left-hand side of the screen in our simulation tree, or wherever you have that model tree normally laid out. So very quickly go through, redefine anything that you might need to alter throughout this process. And that's really one of the ideas here, is that you're able to set this up from the very beginning. And as you keep going through and working with the design, you can make changes, rerun analysis, switch between different ones. So actually with that, you can have multiple different simulations laid out, which can all be saved in the model. Where in that process, you're really going to have one of those active at any one given time, but you can switch between any of them to see exactly what you want to see. So you can have two different structural, thermal, modal study, a flow analysis, all these different things set up, but simply just go through and select the one that you want to work with at any one given time. Now, let's take a closer look into the models themselves and how the system runs its analysis. The first thing here is when we're running analysis on assemblies, these are defined as bonded assemblies. What that means is that any connectors or any touching surfaces, they're going to be treated as bonded. And now the analysis is going to be run on that bonded model. What that helps us to do is get rid of the problems we typically see around things like singularities or interferences that would normally give your FEA tool problems and would stop you from being able to run it. With this, we're able to go right through those problems and simply run the analysis. And running that analysis is something that can be continuously done right in the background. So any changes that we make to our designs, it's going to automatically, as soon as we make those changes, update the results for us. We can also take any analysis that we created in our Creo Simulate module, which is, if you've worked with that before, it's something that we've had around for a while and works on the Mechanica engine. It's really another option that we have for more high-end, highest fidelity FEA analysis in Creo. We can leverage anything that we have there, any load sets or any constraints that we have laid out in the past, and we can work with them right here in CSL as well. And as we do with a lot of our different tools in Creo, we've worked CSL to be integrated in seamlessly with some of our other extensions here. So for example, here we have the Design Exploration extension, or DEX. And this is something that is part of our just base packaging nowadays with our subscription-based model, something that comes right with the Design Essentials, something that integrates very well in with Creo Simulation Live. I guess as a base for it, what the DEX tool is, or Design Exploration, is our tool for trying out new design ideas and exploring new iterations, doing that within existing designs. And it's our way of keeping track of all those decision points that we make. So throughout that process, you're not doing what you would normally do, where you're clicking File, Save As all the time and making copies and putting them in different folders. We end up with all these different versions of the parts. None of that. We're working right within one design session, a design exploration session, and we go through and build checkpoints throughout that. So we're not doing save as all the time and creating different versions. It's just all managed in that one session, and that's something that works in really well with Creo Simulation Live. Now, what we can do is basically go through and make all these different changes to the part, and as we're making changes, building out checkpoints, and right along with that, seeing what that does to our analysis. So I'll go through and show how that works in the process of working with CSL, but it might make a little bit more sense once we go start actually seeing that in the context of Creo. And quickly touching on here is the results. These are really interactive. So once we're in the analysis, we have different display options available to us that we can alter for whatever our use case might be. Then depending on the mode of analysis, we have different options for visualizing on the results. For example, in a structural study, we could display deformation, von Mises stresses, principal stresses, and then the model visualization itself can be altered. And we can go through and show that as well, where you can view different surfaces, iso surfaces, mins, maxes, and then to really understand and start to internalize a lot of those results, we can even animate on the deformation. That allows us to very clearly see, based on how we set up our constraints, our loads, whatever it is, very clearly display what that's doing and if it makes sense based on the way that we define the study. And I actually see a question coming in too, and I think the question is essentially based around how do the results that we get from CSL compare with what we would get from a traditional FEA tool? And that is a really good question, right? So the first step to answering that really is the fact that these two different tools, what you'd see in a traditional FEA tool and what you're working with here in CSL, they're used for completely different reasons. What you would use a traditional FEA tool, it's a validation step. It's going through and saying, okay, based on how I build out my model, is it going to be within a certain factor of safety? Is it going to be under this certain von Mises stress or that kind of thing, right? And what you're using Creo Simulation Live for is more to say, okay, here's my model. As I add material, as I remove material, as I make all these changes, what direction am I moving in? And what can I do to start to optimize around this? If I want to move features around or add features in, what is that doing to the values that I'm getting? And specifically around the results you're getting, you're still able to get very accurate results. You can get between 90 up to 95% of what you would get from running a full study in a traditional FEA tool, which normally would take you hours to run through. And that's not really the idea, though, is whenever you're building these things out in the process of the design, you don't need to get to that final convergent value that you would typically get by running the simulation for hours. We don't need to do that here. We just simply need to know, okay, if I want to add in different parts around this model, if I want to remove this beam or add things around here, what is that doing to the values that I'm getting? And so, again, still getting very accurate results, but it's not going to get to that final level that you might look to get with the validation. And I guess that is kind of the other side around it too, is that Creo Simulation Live here and working with this is not meant to take the place of your validation step at the end. It's meant to work by the time you get there, and by using Creo Simulation Live throughout the process of the design and building things out, you're much more not over-engineered and much more optimized by the time you get there. So you're only, instead of going back and forth between that analysis at the end, which could be either time intensive or cost intensive, by the time you get there, you can get it right the first time around. So you're really cutting down that time. You're cutting down things like prototypes. So that's really the line between those two things. And an important part to bring up too is that this isn't meant to be the end-all be-all that you use to validate your parts before sending it out to the field. But good segue to make there, and good point to bring up. Now, quickly moving forward here is just around some of those results that we're getting. So first, we have our analysis legend up in the top right hand. And actually, the one we see here has been updated for the new look and feel in Creo 7. But what it allows you to do is go through and really interrogate the model. So you can change the scale for whatever your study is, change the units for whatever our need is, and then also the ability to query on the model as well. And what that allows you to do is pick out specific areas or different surfaces that you want to get more information on. And that information is something that we can also get from our simulation probes. So we can see how specific values are changing as we go through and make changes to the study. And as we're working with this, we can highlight and annotate on minimums, maximum areas in the model to really give us further insight into our process. And once we're finished, we can then export our results to an HTML report to use off however we might need to downstream. And so that's just a base quick overview of some of the general improvements that we've made to core modeling. And now what I'd like to move into a little bit here is talking into specifically what we have with new improvements in Creo 7. And so again, like Stuart mentioned earlier, this has been a relatively newer product in the grand scheme of Creo. It's been in development in Creo specifically for almost 2 years now. And it's been a tool with ANSYS for longer than that. They actually have their Discovery Live engine that they've been working on, but we're adding a lot more functionality here in the context of Creo as well. So the first thing that we've added is the ability to control the direction vector from a selection. So it doesn't have to be off of a default, and so you can actually select right in the model where you want to define your direction vectors from. And that's really helpful for laying out loads, moments, forces, that kind of thing. And building off of that, you're now not only not locked down to working with the whole global coordinate system. You can now build out any coordinate system that you want to use to define those load cases from. So it's just improving the general ability to define those loads at the start of the study. Like I mentioned, we also made enhancements to the legend. So specifying what you want to look at, exactly how those values are displayed, and especially for setting up things like upper and lower bounds for values that you're displaying. So it works very well with what we have in our composite views. We are only displaying values within a certain range on our legend. And we can also use values that we get from the simulation probes over in our behavior modeling studies. And if you haven't worked around behavior modeling in Creo before, that's something that allows us to take values like your maximum von Mises stress or displacement in a certain area and actually optimizing around it, where you're telling the system certain dimensions that it can change, and then the system goes through and automatically optimizes the model for you. So based on what you allowed it to change. So it's a really very useful way of using those analysis results. And another way that by the time we get to our final validation, we're much more optimized and much less over-engineered. And touching on this here, we also added more real-world simulation constraints types, things like ball, pin, and planar constraints. So it's helping us to make each of those cases more realistic to the problem or the situation that you're trying to design around. And this might be something that you've seen with the release of Creo 7, but now CSL also has support for things like multi-body design. And there's really a ton of different applications of that. Things like cavities, internal, external volumes, domains, and really much more around this that you could build out now with the use of your multi-body. And then specifically to thermal studies, we can now have the option to do transient studies, aka time-dependent analysis. It allows you to see how your results are changing over the course of time. So now you can either do that steady state, like we've been able to, or also now time-dependent, which is another side of that. And finally in here, probably the biggest change to CSL with Creo 7 is now the option to do flow analysis in the same way we do for structural, thermal, modal. Where with this, we start out by essentially, we're just creating the fluid domains, stating which areas to include, exclude, define inlets, outlets, then specifying things like our domain, the materials that we're using for the fluid domains, and then from there, visualize it right on top of the model that we're working with. And that's the idea with this. It's regardless of whether it's an internal or an external case, be able to visualize it right on the model environment that you're working around. And along with that, which we'll see, there's a ton of different options for the results that you're getting. Visualize streamlines, particles, taking section views, direction fields, setting up probes. So really powerful, but at the same time, really easy to use tool for doing that type of flow analysis. And it's something that's built for the designer, the engineer that's working with this. It's not something that we have to send off to an expert analyst, something that we can start to use right away in the design environment. Perfect. And so that's our base overview around that. Again, if there's any questions, feel free to drop them in at any point and we can touch on them. But what I'd like to go through now and do is show a couple examples of this and how this works in the context of Creo. Let's go ahead and pull up what we're going to be working with here. So for our first example here, we're going to be working with a data set that we have from one of our customers, Polaris. This is actually the cast iron chassis body off of one of their snowmobile assemblies. And so this is something that you can imagine with something like a snowmobile goes through a lot of different scenarios, right? It's going to be going through different vibrations and structural considerations, thermal flow analysis probably in here in the middle. There's probably a heat exchanger that we'd want to look at. But just really a great thing for looking at in the context of Creo Simulation Live. And the first thing that we'll do is step in down here in just the part level. So go through and see how we define out one of these studies just as a base. And as we keep going, we'll take a step back a little bit later on and also see how this works back on the full assembly level as well. Now the first step here is going to be defining whatever the material is. In this case, it's just going to be aluminum alloy 6061. From there, just again, just select your live simulation at the top and select the type of simulation you want to run. From there, we'll do a structural study and define our base constraints. So saying which areas that we want to have fixed down here. In this case, we're going to fix the central board down at the bottom and then go through and define whatever loads you want to study. So we can look at forces, moments, pressure, gravity, centrifugal forces. We've also added acceleration. And these are all things that we can go through and study on. In this case here, it's apply a couple surface forces along our part. And while we're going through this, one of the things to notice is that normally with a part like this, you would have to defeature it completely. You would have to get rid of any small holes or rounds or any interferences that you're getting. But with Creo Simulation Live, we don't have to do any of that. We simply just leave the part as is, say what kind of constraints that we want to lay out, what loads that we want to study, and that's it. Leave everything exactly as is and click through to simulate. There we go. That's how fast we can get results back. It's really that fast. It's something that we can go through and now start to see exactly what we're getting based on our design. We can also animate on that. So based on how we define those constraints, define those loads, see how that's actually deforming in the way that we wanted it to, or maybe we even just expected it to. If you want to see a bit more of a true to life, less exaggerated form of that deformation, go through and see that here as well. In this case, seems to be deforming the way that I intended, so we can go through and start to look into other values that we're concerned with, such as our von Mises stress if we'd like to. But there's also a lot of other result types. We could see our normal stresses, shear stresses, principal stresses, things that are all really related to what we're looking at in a structural sense. Go through, change the units, change the rendering method, show where we have minimums, maximums, and start to really look around those areas. So down here, we can see on my trajectory rib at the bottom, we're actually starting to get a bit of a spike there, or max, in what we're seeing in our von Mises stress. But I'm also going to get some numbers around that to see as we're designing what we're doing. So as I start to build things out, I want to see what our von Mises stress is doing, if it's lowering down, if it's raising, and that's going to start to kind of guide my design changes that I'm going to make. And this can be done in a lot of different ways. So like here, if we wanted to use something like our direct modeling and our flex modeling, we could simply just say, hey, I want to take those surfaces, move them out by however much you want, an inch, whatever it is. Have all those adjacent surfaces update for that change and have that update in my analysis as soon as we go through and increase that wall thickness. Here we go. So we can see that number updates is now down from around 55.7 down to around 52.8. And that's really what we want here is as we're going through and doing things and making changes, say, all right, I want to know what happens if I increase my radius. Well, I don't have to send that off and hope to get results back. It's something that I'm right in my design environment. I make the change. I see the result. That's how we want to be doing design, is not based off of intuition and just guessing, but off of feedback and really building off of that. You can see down here, actually, max von Mises stress has changed down to another part. Now that's something that we could go through, build around, build out new features, increase the material around there, start to really optimize and build around this model. And like I mentioned earlier, actually, one of the really good ways of doing this is with our design exploration extension. This is something that's based with everything that we have in our design essentials. And you simply just go through here, give a name for our study, and begin into this with a pre-modified version of the model. So this is something that throughout this design session that we do, we're not going to be making any changes to the model itself, but we're simply building out a list of instructions that we'd like to be applied to the model at any given point. So we only actually really make changes to the base part once we've accepted any of those. So until then, it's all just simply kept track of really here in the checkpoint tree. We can make checkpoints for any of those, build off of them, make branches, new iterations. And once we're happy with any of those iterations, we can accept those changes, and then they're all applied to that pre-modified version of the model. And once you apply them, you can still go back and reference that session, see any of those different iterations. Maybe if down the road you change your mind, you say, you know, I wanted to see that other iteration, see with those different features what it looks like. That's no problem. You can simply just open up the session at any given time and reference back to that. So here we can go through and now start to make changes. And based off of what I saw in my initial kind of study here, I saw that most of our stresses are around that center bore down there. And now what I want to do is start to add in some trajectory ribs and start to spread out those stress values that we're getting a bit. So I want to make sure that if I want to go through and add any of those ribs in here, that it's not going to be shooting up my von Mises stress. And again, what we're doing here, this is just standard Creo work. This is just your standard thing that you would do on any given day-to-day basis. Going through, doing extrudes, making rounds, whatever it is that you'd be doing normally in your design process, we're not changing that. It's still staying exactly the same. But as we're doing that, we're getting that instant insight into saying, what does that do to my von Mises stress? Does it shoot it up? In this case, no. It's only going up from about 29 to 32.6. But we do see it's increasing, but maybe in that case, it's going to be good because it means that those von Mises stress are being more spread out along the face of our part. If we like that, we can build that out as a checkpoint, give it a name, and reference back to it at any point later on. In this case, I'm pretty much happy with the part that I started in with, so I'm going to leave it as is for now. Okay. And as we can see, very straightforward, very easy to work with, especially if you're someone that designs in Creo, this is going to be a walk in the park for you. It's working with the same user interface that you're used to. But as we start to increase the level of complexity, right, maybe we're working on something like this. It's going to be more of an assembly with a lot of different features and sub-assemblies, parts, all these different things that we have to take into account. But the nice thing here is that the process actually stays pretty similar for working with CSL. What we'll do first is lay out any constraints that we have. Maybe it's going to be fixed in the back here along this chassis body. And then we can lay out whatever forces that we're going to study. In this case here, we have some loads applied over in the front, where we have a downward force over on the right. And then that could cause a resulting upwards force over on the left-hand side. Okay, now looking at this part, there's obviously a lot more happening than just on that part level, right? There's a lot more happening. There's lots of little holes, rounds, interferences. I think on this assembly in particular, there is 2 or 3 dozen different interferences. And if you've worked with FEA at all, you know that that would normally give your FEA tool fits. It would really be a struggle to get the mesh built out properly, and could take sometimes even days to get this model to the point where it could run through analysis even to start. Then if you wanted to run through the analysis, it could take hours, or it could even, might have to set it to run overnight. And you could have things like failures where you have to go back and redefine things and run through the whole thing. And that's something that really we want to avoid. Us as the designer, we just want to see and get insight back into what we're doing here and the effects of the designs we've been built out. So all we want to do is lay those initial constraints out and click to simulate. There we go. So just as fast as we do in the part level, we can get results back here on the assembly level as well. And this isn't something that I sent off to hopefully, get results back by the end of the day or the end of the week. Something that I'm right in Creo, I set it to run, and I see exactly what's happening in my model. So again, we could go through and animate on that deformation, see kind of what it's doing here. based on how we applied those loads, applied those constraints. So obviously it's moving around a decent bit up in the top right hand relative to the rest of the chassis body. Now let's go through and actually start to interrogate that a little bit more. So if we want to go through here and apply another simulation probe, and simply just select on one of those faces, say, okay, what's our maximum deformation on this surface? And right now we're sitting around just 1 millimeter deformation. Now it's something that I can start to design around. And in the assembly mode, I can actually add in parts, delete parts, add in full sub-assemblies if I wanted to. So actually over here, I have a sub-assembly suppressed over my model tree. So let's go through here, exit out of insert mode, and add in this more support canopy that is attached to this chassis body. So we see we add that in, it updates the surfaces, and actually updates right there on our probes. Now we're seeing down to around 0.34, where we were at just around 1 millimeter deformation. And that's really what we want here, is to say, okay, if I add things in, change the materials, whatever it is that having the effect that I want on the deformation? Is it moving in the right direction? Really helps me to build and essentially actually replace assumptions that you would normally be making with just your intuition with facts and stuff that you're actually getting insight back from simulation line. So that's a good look through both a example on the part level and the assembly with the structural, but obviously there's a lot of other different ways and different types of simulations we could go into as well. So let's go through another example here on this part in particular. So here I want to look through a modal example. And so with laying out a modal example, essentially all we need to do is apply the constraints that we want to look at. These could be in the same places that it had with the structural. It might be welded down there. We might have a couple beams back through there. So we'll lay that out. And in this case here, going through this, I actually want to take a look at what the effects would be without the support canopy first. We can go back here, roll up that insert mode here, and just simply look at the chassis body, and then click to simulate. And what we're looking at here is essentially, with using different mode sets, what is going to be the frequency response of the model that we're working with. So it's helping us to design around particular areas where we want to avoid certain frequencies. We can actually see the deformation magnitude here in the model and see, based on changes that we're making, if we're lowering that down, if we're raising it, if it's really the natural frequency that we're looking for. So we can animate on that, really clearly show how it's going to deform, and change this around to different mode sets that we want to study. And with those different modes, we're going to get very different results here in the model. So we get our deformation magnitude changes a lot, exactly where in the model it's having an effect is changing. So definitely giving us some insight here into this model. And it works the same way as if we were working with the structural mode, right? So if we want to go through, make changes to the model, add in that support canopy, you can see exactly what that does to the analysis results that we're getting here in the modal side. Now let's go through here, change around any of these to study. In this case here with our new mode set, we can see we're making changes here, maybe raising up that deformation magnitude, lowering it down, whatever it is, whatever we want to design around and keep our part into the most safe area possible, depending on the mode set that we're working around. So here we're definitely seeing a big change in not only deformation magnitude, but also what that's doing in the model itself. So very useful thing there, and something that we can start to work with. Now I would like to take a quick look at just a thermal example, just so you can kind of see a little bit about what this looks like here. And for this one, I'm going to switch over to a heat block. So this is actually an engine block that we're going to be working with here. And it starts to kind of lay out in the same way as before, where we lay out essentially whatever we want to look at here in the assembly level and the part level. In this case here, we want to apply some boundary conditions like our convection. And what I've done is actually lay out a couple different surfaces that we want to study here. We can see exactly where that's being applied to around our part. And with that, we have options. So lay out the convection coefficient, bulk temperature values, and then move on to laying out things like the loads, including heat flow, heat flux, and then say exactly what that's doing. So in this case here, it might be applying a heat load right on the top here of 1,000 watts. So change the value, change the units, whatever you need to go through and work with the study there. And once we're happy with that and we have those laid out, we're simply ready to go through and click to simulate. And very quickly, we can go through and see the impact of the changes that we have. So we can start to look at this, see where we're getting hotspots in the model itself, go through and actually visualize on exactly what that's doing here. And we have the same type of results that we can go through and look at there. So we can change around the temperature that we're seeing, see different composite views throughout the model, and really change around these things to get things looking in the way that we want for our analysis results. So we can look at it in Kelvin, look at it in Celsius, and see what that looks like here on the model. And kind of like I mentioned earlier, we can see maximums, minimums throughout here. And also, if you wanted to go through, and what this is right now is more of a steady state example, but we also have the option to go through and do more of a transient study as well now. So options there. And now what I'd like to actually switch over to and work with is more onto the flow analysis example that we want to do. And for this one, I'm actually going to switch over to working in Creo 7. And this is going to be with a different data set. So this is one that we actually have off of one of our customers, Royal Enfield. They gave us a really cool data set to work with. It's actually one of their Enforcer motorcycle designs. And this is the muffler off of that motorcycle. So this is going to be a really good candidate for working around flow analysis. Something that, we're going to have stuff coming out of our exhaust from the engine, and something that we want to start to design around and really build out the best way possible. So what I'll do first is kind of take a section view so we can see what's happening in here. So we can see a couple baffles towards the front. We can see some holes and some pipes going through towards the beginning of that inlet flow. So something that's going to be really good to work with. There's a lot of good geometry that we can build around and really start to optimize and design with. So to start into it, we'll simply go right up into our live simulation tab and then click to add the study that we want to work with. So here we'll go over to our flow analysis and lay out the basis for our study. Now to work in the flow analysis, the first thing that we'll do is lay out our domain for the study. So this is our fluid domain, essentially the volume of space that our fluid flow is going to be contained within. In this case here, we're working with an internal volume because it's going to be more of an internal flow example. But we also have options for doing it as an external flow where it's moving around this body, or even if you're using kind of more of a multi-body Boolean approach, you could actually work with those bodies and have those be what's defining the, fluid domain for your study. In this case, what we're going to do is essentially take whatever geometry we have and have it define the actual domain for the study. And all we need to do is lay out wherever our inlet's going to be. In this case here, right at the front. Switch around to the back for our outlet. Once we just kind of lay that out, the system automatically defines the internal volume for the model. We can check that off, and now it appears down in the model tree. And that's something that I can go back to later on, make changes if I'd like to. But in this case, I'm pretty happy with it. And from there, I can start to go through and define our material for the study. In this case, we have some base examples here in our material directory for air, carbon dioxide, mercury, water, water vapor, really covering a lot of the different examples you'd normally go through and work with. In this case, carbon dioxide is going to be a really close approximation for what's coming out of my motorcycle. And with that, we can move on to setting up the fluid flow velocity for my muffler. Essentially, how fast is it going to be coming in from my motor? So here we'll go through, specify the surface that I want to work with, and then define the direction, and also any units or magnitude for that direction. Say OK. And now that we have our flow velocity set up, we can also go through and define some thermal conditions, such as our prescribed temperature at that inlet. So we can set the value, set the unit, whatever our regular operating temperature might be around that motorcycle exhaust. I'm pretty happy now with some of the initial conditions I have at my inlet. So next I'll also define down in my outlet some of the pressure for my motor. So moving around to the back end, in my case, I'll just simply set it to 0, essentially just outside air there. With that, I'm pretty much ready to jump into the study. So we do have some quick options that we can change here for the, the fidelity of the study, the quality that you want to run here. So this is something that you have available for each of the different result types that you're getting, or the different simulation studies that you're going through. So here you can slide it all the way to the left for the maximum speed, keep it all the way to the right for the highest accuracy, or maybe lay it somewhere out in the middle. In this case, I want to get to the highest accuracy possible here. And with that, we're ready to go ahead and, like we have in the past, click to simulate. You can see again, essentially as soon as I click to run the simulation, we're getting results back. It really is that fast. I have the ability to change things over on my legend if I only want to see the velocity in a particular range. We also have different display options that I can choose from to visualize in the flow. So for here, we have the individual particles. And even with that, more options for the particle to change the size, the transparency, really getting things looking the way that I want. Helps me to understand a lot better how that flow is working depending on how I set my model up. The particles are one great way to analyze the flow. We can also look at things like a direction field. This acts as a cut plane that I can use to see the direction everything's going. I can move that cut plane around to different parts of the model. So here I can actually pull up our dragger tool and change that around, move it around to see the direction that my fluid is moving based on how I defined it. Helps me to really interrogate certain areas. I can even type in specific values for that section view if I want to. As we can see, there's really a lot of different ways of visualizing on those results, but also start to analyze on that and build off of that. Starting here first with our live simulation probe. So like earlier, it allows us to see different values in my model, such as the maximum velocity that we're getting at our outlet, and see how that changes with our flow. We can see that. We can also see a graph of that value, see how it's changing. It really helps us to see what's happening at that outlet. We have options to see also pressure, temperature, vorticities. So now these are all things that we can start to actually design around. We have a lot of different ways of doing that. And as we've seen with the structural example, we could also do this by working in the design exploration extension. So here we could start to really try a lot of things out, be creative, do new designs, iterations, branches, try things off of existing designs. Instead of making all those different copies, just stay right within the session. And as we go through and make these changes, so here if we wanted to say increase these baffles, see, okay, what happens if I increase the length of each of these? Is that going to change how the flow is working? So, and again, like we can see here, even as we're right within the design exploration session, have all this flow analysis running, we're still doing normal CAD. We're still doing this Creo work that we're used to. The difference is now, as soon as I make the change, we get that instant insight into what that's doing to our flow. So I can go back now, see what that does to those particles, see where the velocity is increasing or decreasing. It's especially important down to my end velocity. So we can check that probe, see how that graph is changing. I mean, this isn't something that I send off to analysis, hope to get results back later on in the week, and I can start to design around that. I just make the change, I see the result, and I build off of that. So here I can build a checkpoint out like we did earlier and simply keep moving on from there. And what this allows me to do, working in design exploration, is keep making changes to my design. So maybe now in a past design, I may have built out these pipes with holes in them because it might make a big change to how that flow works. Well, now let's see what happens if I go through and actually activate on those holes. So right down in the model tree, activate those and show the results here in our flow analysis. So immediately we're seeing a very different flow type down by outlet. So we can also go through, check the probe, check the graph, clearly see that we've started to increase that outlet velocity, but we can check other values as well. So switching more to our composite view, we can see how the velocity is moving through those pipes. Check the pressure, seems like we definitely smoothed out the pressure flows throughout that whole model. That might be useful in order to see where our max values are in the model, kind of have those pushed to the front of our view here. Similar to how we did with that direction field, we can take true section views to see kind of what's happening at different parts of the model. So let's switch around here to the back end and take a closer look at what that flow looks like through the holes that we added in through the pipe. We can see the difference with that or with the direction field. Actually, looking at that, we almost reversed the flow through those holes in the baffles. I'm definitely happy with the changes I made so far. And to capture that design intent, I'll make a checkpoint to show right where I was when I made those changes for the holes. It's something that I could check back on, switch between different checkpoints, really starting to capture the work I've done throughout this design. Now, I'm pretty happy with where I'm at towards the outlet. Now I want to start to move my direction more towards the beginning of the flow here. Right now, we basically just have a solid cylinder with a bunch of pipes going through it, but I kind of want to start to change up on that design. So first, let's go through and clear out that feature I have right now, and instead start with a clean slate that I can begin to add to. We're also going to use one of our multi-body commands here. So very quickly remove that body from the model here. So that's another Boolean operation that's something available in Creo 7 now. And what I actually want to go through and do is add some new geometry. And what I want to do is actually add in a lattice feature here to regulate the flow through this channel. So this could be something that we're going to create using additive manufacturing. And around that, there's a lot of options. So starting into this, we'll first define the surfaces or the area that we're going to use to define where this lattice should be placed within. This is what we call a lattice region. Let's go through and simply select on any of the edges that we want to define that region. Now, latticing, if you haven't seen this, this is a feature that we've been having a big focus on over the past couple of releases of Creo. Really gives us the ability to create some very robust, complex structures that have a lot of different uses, especially if you're working in the world of 3D printing. So with that lattice, we can quickly define our coordinate system, where the first cell is going to be located. We can change any of that and define what our cell shape is going to be. So we have different options for triangular, hexagonal, octagon, whatever you want that to be. You can shape it up, size it down, a lot of different options to do that there. And finally, I think this one looks a little bit thin, so we can change some parameters, change the wall thickness, add a radius, check out what that looks like, and if we're happy, accept those changes. And again, even though I made a fairly significant change, the analysis has already been updated, and then we can analyze the effects of that. So let's go through, change some of the display states here, change the result type, see what that looks with the wireframe, check out what that did to our pressure around those lattices. That looks good. We can check back around towards the velocity of the outlet of my motor and see kind of what we're getting in terms of values there, and check the graph to kind of see what that's doing, where we're getting spikes in values and where we're settling out around. And once I've had the chance to look over any of those results, and because I'm in Dex, I build out a checkpoint. Allows me to see exactly the changes I made in order to get here. If I'm happy with those changes and where the design's at, I can accept all those changes, and what they do now is be applied to the model. And now that's the one I started into the session with. And even though the design exploration is a great tool, I don't even have to be in Dex to make changes, right? This could be a day or two later, or someone on my team says, "Hey, Paul, we need to decrease that outlet velocity more." Well, maybe to decrease that outlet velocity, a good place to start is going to be around the outer diameter. Probably going to want to increase that a little bit. So once I make that change, we simply just regenerate the model. My analysis updates right along with it. Now I can go back, check the probe, see what values we're getting there. See that we're definitely dropping down the values we're getting around that outlet velocity. So we're getting right around 240, 250 meters per second. And so that's really the idea of flow analysis in CSL. You're making any of the change you want. Try this, try that, try anything. We don't want to limit at all the amount of creativity that we can have in our design by waiting for those type of results to come back. We simply just make the change, build out the model we like, and immediately get that insight back. Okay, and so that's a couple of different examples that we have there, from structural, thermal, modal, and the flow analysis. And depending on exactly where you're working at around there, a lot of different advantages and a lot of real value that we get from working with that. So overall, with any of these, it allows us to perform this analysis early and also often throughout the process. So we can do this all throughout. We're not getting to our validation stages where we're going to have rework and that type of thing. We're getting things right a lot of times the first time around. So a lot of people, honestly, that we've talked to haven't done any analysis up until this point. So this is something that now we've built out and you can do throughout the process. And this is also reducing things like time to market throughout this really concurrent design and analysis process. Helps us to explore new design ideas, instantly identify and resolve on those flaws much earlier in the process. And we can really start to design to price premium because we have these high quality, high performance parts. And through the use of our simulation driven design, we're creating products that perform a lot better, more durable, and most importantly, at the end of the day, is going to be in a much higher quality. And overall, we're reducing a lot of it around our product development costs, cutting down on rework, cutting down on the prototypes we're creating. And all of this is really because we're able to get our designs right the first time around. So that's our general overview around that. And what I can do now is pass it back over to Stuart, wrap up, take any questions that we might have. And then if you have any after the call, obviously reach out and we can get this answered for you. But for now, I'll pass it back over to Stuart.
Actually, Paul, we do have one more question. Does it work with dynamic loads, random PSD curves, shock response, and spectra?
Good question. And no. So anything that you're doing in dynamic, this is all going to be static linear. So that's going to be essentially everything that you're working with in the context of CSL. If you get into working anything around dynamic cases or contacts, that kind of thing, then you would stick to working with your standard FEA solution if you're working with ANSYS or Creo Simulate. Just stay and work with those scenarios in that sense. And that's really the idea here is you can work with anything that you have in the static linear case, which is going to be a lot of times what you'll be working around. And then by the time you go through and do that type of dynamic study, everything else has been done around that.
I think that's all the questions that we have at the moment. So I'll give everyone another chance if there are any other questions. At this point, if you are going to ask a question, if it's easier for you, you could unmute yourself and ask away as well, or use the chat session. All right, well, I don't see too much else showing up. So just a quick reminder, we did a previous presentation on what's new in Creo 7. We did, of course, mention some of what you saw today. So there's a little bit of overlap there. But if you have any questions about Creo 7, you can, of course, watch that video. We have all of these videos on our YouTube account. You can reach out to me as well. Or if you wanted to try it, if you have a subscription, you can just download and go ahead and install. There's nothing to purchase. So if there are any questions about Creo, CSL, or Creo 7.0, please let us know. But otherwise, thank you very much for attending. Hope this was helpful, and look forward to seeing you again in another session.
Thank you, everybody. Have a good one.
Thank you, Paul. And Paul, thanks for your support today.
Yep, no problem. Have a good one.
Thanks. Bye, everyone.